Hi guys. Here we are, just chilling in the 1920s. We did a little time travel, if you will.
That's right. So we just thought we'd kind of jump back a little bit so we could talk about the golden age of atomic theory.
Woo!
Yeah, pretty fun. All right, so atomic theory kind of started in 440 BC.
Long time ago.
Yes, longer than the 1920s, but short budget, short jump back in time.
The DeLorean could only go back so far.
That's right. So Democritus was the first guy to really kind of think about the idea of atomic theory. So he said something like, well, if I keep cutting something in half, how long can I cut it for?
Ooh.
Infinite number of times? Will it ever end? Does it? Who knows? Can we test it? Not at that time. All questions he was asking himself.
Oh, okay. On a Friday night, probably, right?
Every night was Friday night for Democritus.
Well, you're probably true. Okay.
So they came up with the word atomos, which is Greek for indivisible, which...
Kind of goes with our word atom.
Yeah, shocker. You might look familiar.
Atomos, atom, Greek. Now I know not just 7 languages. I now know 8 because now I can say something in Greek.
Yes, you are now fluent in Greek. All right, so there's a little bit of jump in time here.
Oh,
You know, like
boom.
2,000 years.
Yeah.
Done.
Wow.
Yeah.
Okay.
So John Dalton, pretty cool guy, school
Really?
teacher.
Oh, well, he would be my friend.
Meteorologist. Yeah, probably not mine. He came up with 5 principles of atomic theory.
Oh, so he kind of like took Democritus's work and kind of studied a little bit more?
Yeah, exactly.
Okay.
Now, bear in mind, we kind of skipped 2,000 years, so there was some pretty big stuff happening during that time with like Lavoisier and other cool guys. But we'll just skip them for right now.
Okay.
So Dalton took pretty much all the atomic theories and he kind of condensed it into 5 simple to easy to remember principles.
Oh, that sounds easy enough.
Yeah,
5.
5, not
That's
hard.
on one hand. You can totally do those. Okay, great.
All right, so 1, all matter is composed of atoms.
Oh, well, that's simple. Right.
Yeah.
Anything that's matter has got atoms. Okay,
Touch
done.
it, atom.
Check.
Boom. All right, atoms of the same element are identical.
Well.
Yeah, you know. Yeah.
Okay.
And you know what? He's still famous, right? Like, come on.
All
we
right.
we can come up with something.
Yeah, okay.
Right? So, one gold atom is the same as another gold atom, same as another.
Oh, God. Okay.
So, you know,
Yeah.
kind of works out that way.
Okay, that works easy.
Yeah.
Okay, that's 2.
That's 2. So, number 3, law of conservation of matter says that matter is neither created nor destroyed in a chemical reaction.
All right, well, that's pretty simple.
Yeah. So, you know, if you have 10 grams, you're going to end with 10 grams.
Okay. So it's just going to, like, probably look a little different. Might rearrange or something?
Yeah, exactly.
Okay.
Exactly. So, I mean, it won't look the same, and you might have 10 grams of liquid in the beginning and 10 grams of gas, so it might be a bigger amount physically, but
Okay.
it's still going to weigh the exact same.
So it never disappears.
Never disappears. You cannot create nor destroy it.
Okay.
It gets a little funky with, like, nuclear reactions and fission and fusion, but you're still not creating or destroying matter. You're
Okay.
just changing it into different
We can do
things.
that. That's a problem. No
Yeah,
problem.
so in this example, if you'll notice, we've got 4 hydrogens on the left side, and we still have 4 hydrogens on the right.
Oh, okay.
On the left, it looks like a gas. On the right, it's part of water, but it's not created or destroyed. It's
All
still
right.
just there.
So if you counted just the circles, if you will, in this picture, white versus red, you still have the same number on both sides.
Exactly.
Okay.
So it's conserved. Moved around, rearranged, but still conserved.
Okay, so that's 3. Got it.
Yeah, so this guy's getting pretty cool.
Okay.
All right, so now we got number 4. They're getting a little
Okay.
trickier here.
All right. So wait, let's rewind one more time. First one was all things are made of atoms.
Boom.
Right? All matter is made of atoms. Okay, done. Anything that's a gold atom is a gold atom is a gold atom is a gold atom.
Yeah.
So if you're something else, you're something else, you're something else.
Boom.
Okay. 3, matter is not created or destroyed, just rearranged.
Exactly.
Okay, and now we're on to 4. Got it.
Now we're on
Okay.
to 4. All right, so this says that atoms will always combine in whole number ratios.
So you never have like H half O.
Thank you.
I felt like that should have been a little more
Hey, I was
fluent.
I was expecting a longer thing. Yeah, you can't have half an atom because remember, atoms are indivisible.
Right,
Our,
so-
our dog Democritus told us that.
Our dog. Do you know we used the word dog in the 20s? Our
Yes.
roaring friend.
Our roaring
Pal? I don't know.
Yes. Our pal Democritus told us that you can't divide them, so then they have to be whole number ratios.
Okay.
Now, all the molecules of one compound are going to have the exact same ratio. So, for example, water will always be H2O.
Okay.
So it will have 2 hydrogens, 1 oxygen, every time, all the time, never change, never be different.
So no matter if I'm talking about a little cup of water versus a giant swimming pool of water, it's always 2 H's and it all to
Exactly.
make water.
I can drink some water here from the 20s, H2O. Drink it when we get back to 2015, H2O.
Got
Same
it.
thing.
Okay.
Will never ever change.
Sounds great.
All right, and then last but not least, our fifth principle of democracy of atomic theory. So this is going to be that atoms can combine in more than one way to form an element or a compound.
Oh.
So
this one's a little bit more tricky.
This one's tricky. They get harder.
Okay.
They get harder.
Okay.
So in 4, we said that the combination of any compound is the same. So H2O is H2O is H2O is H2O.
Got it.
Number 5, we're saying H's and O's don't have to be H2O. They could be different.
Oh, okay. Well, then I get it. So, like, you have water, which is made up of 2 H's and an O. But then, like, for example, you can also have hydrogen peroxide, which still has H's and O's, but they have different ratio numbers.
Exactly.
Oh, okay. Then that makes sense. All right.
Exactly. So things like, let's say, C's and H's, one ratio makes, like, natural gas for your stove. Another ratio makes gasoline for your car. Similar, but still different.
Oh, I totally get that now. Okay.
All right, so jumping on ahead about another 100 years. That's our jump. Well, I guess we're walking, marching through time. We have a buddy, J.J. Thomson.
Ooh, do you think he had a real first name? Like, was he with John Jacob, or did he just always straight J?
Shit.
Oh, classic.
That's probably, that is classic. I feel like I should do that. C.C. Wood.
C.C. Wood.
Maybe I'll go by C.C. Wood.
Ooh, I kind of like that.
I like that too. It makes me sound like I know more than I really do.
That's true.
So, J.J. Thomson. Now remember, at this time, electricity was kind of big, right? So
Right.
they were doing a lot with electricity.
Yeah.
So what J.J. Thomson used was a cathode ray tube.
Ooh,
Super
sounds
cool,
very
super
exciting.
fun name. It's kind of a precursor to a TV tube. That's my
Okay.
precursor.
Oh, that's a precursor
Yeah.
notion. Okay. Now we're talking like old school tube television,
Yes.
not like flat screen that
No,
we're
no.
used to in the 2015 back
Yeah,
way ahead
yeah.
of time where we're not.
No.
Okay.
Yeah, old school tube. So what they did was it was a glass tube, almost no air in it, and they passed electricity through it.
So did you think of making a zzz, zzz, zzz noise?
I feel like it did.
Okay.
I've never seen one in real life
Okay, I have not either.
because, they're old.
Yeah, and we're only in the 20s, so we're not even back far enough yet.
Exactly. These are still too old school for us even now.
Right.
So he passed electricity through it, and he realized that electricity was made up of things called electrons.
Oh.
See that? Electricity,
okay.
electrons, electricity, electrons,
Okay.
electricity, see how he went there?
Yeah, got it. Electricity, electrons. Okay,
Yeah,
cool.
that's what he did. In fact, he had this little ray tube, and it went zzz, 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 and it was like a little,
Okay.
and he put a magnet next to it, and it bent the electrons.
Oh,
So
so they had a charge.
They had exactly they had a charge.
Interesting.
So and they bent away from the positive, so he knew electrons are negative.
Oh, okay.
He's a fancy
But don't
guy.
like charges? Like charges attract opposites,
Oh, yeah, I'm sorry. Yeah. Ooh, like charges do attract. My bad.
right?
So yeah, he put a negative thing and it bent away from it.
Okay, so
man.
opposites attract, like charges repel.
Oh, it's embarrassing.
That's okay. I was just a little confused, and I didn't want anyone to be
I
confused.
understand.
So we just cleared it up for
Thank
you.
you. He came up with a super cool model called the plum pudding, but that's for another video.
All right. Well, we gotta get going because we got.
Oh, hold on.
Oh, we.
We still have Rutherford.
Oh no! But the flux capacitor is getting ready to roll.
We gotta do
fired
Rutherford.
up.
We still
Okay.
got one more. All right. So Ernest
one.
Rutherford, 1911. So pretty recent. We just met him, a couple minutes ago.
Yeah.
He had a super cool thing. He shot alpha particles, which are pretty big particles, at gold foil. Don't know why he thought of that. Just for fun, I guess.
I guess.
Rolling in the
Maybe
dough.
it was like Charlie and the Chocolate Factory, and he opened like the wrapper, and it was made of gold.
I bet that's exactly what it was.
Okay.
So anyway, he shot these positive alpha particles at this gold foil.
Okay.
And it turns out that instead of going straight through, instead of bouncing straight back, some went through and then some just got deflected and scattered and went all around.
Oh.
So he was, like you expect it to hit the gold foil and bounce back, right? Or you
Right.
would expect it to maybe go right through the gold foil, but not hit it and then just
Scatter.
do a scattery thing.
Ooh, interesting.
So
okay.
what he figured out from that was that the alpha particles must have been hitting like a dense nucleus and being scattered that way.
Oh, okay. So there must have been some in the middle.
There has to be something in the middle. So
Okay.
Ernest Rutherford figured out that there was something in the middle of an atom. He called it the nucleus,
Okay.
and that there's probably a lot of empty space around it.
Oh, okay.
So what we think of as really solid is actually mostly empty space.
Wow.
Yeah, it's pretty intense.
Kind of mind blowing, actually.
It is, especially because it's like over 100 years old.
Yeah.
Yeah.
That's kind of like a gym. Like from the outside, the building looks huge, and then you get in there and like you can run rampant in there,
You can.
play dodgeball and all those things.
Yes.
Okay.
All of those things.
Okay.
All right. Well, so that is it for us. We do
Okay.
have to go now because
the flux capacitor is running on
We do
low
not have
flow.
we do not have Mr. Fusion.
No,
yet.
we do not. So, all right, well, we're going to head out, and we'll see you back in 2015.
Bye.